Chapter 27, Suspension Systems, Day 1, Video 3, Constant and Variable Rate Springs. So two types of the spring assemblies we've got, constant rate and a variable rate. The characteristics of a constant rate spring is that it deflects or moves the same amount or in a fixed rate the more load that you put on it. So let's say on a suspension that's got a constant rate spring, I put 10,000 pounds of payload on that suspension, and it compresses or deflects down 1 inch. I put another 10,000 pounds of load on that suspension, and it drops down another inch. All right, and then another 10,000 pounds, and it deflects and moves down another inch. Okay, so it is constant with its deflection rate with the weight that I put on it. It will always react the same way at the deflecting the same amount for the same amount of weight that I put on there. A variable rate spring, it gets stronger the more weight that you put on it. They do that by changing the overall effective length of that spring. So we put 10,000 pounds of payload on that suspension, it moves down 1 inch. You put another 10,000 pounds and it deflects 3/4 of an inch, right? So a little bit less, it's getting a little bit stronger. Another 10,000 pounds and it deflects down 1/2 of an inch. Okay, so the more weight that I'm putting on it, the less it deflects. It gets stronger with the more weight that I put on it. So looking at the diagram here, the illustration is an example of a constant rate spring. It's got the multiple leaf layers here. U-bolts here holding the bracket here, or axle would be underneath. Bracket here on the front and a bracket here on the back. Bracket here on the front, so our leaf spring is going to have an eyelet in the end of it, and that's going to engage into that bracket here that's mounted to the frame. So the more, when I put weight on it, it is pushing this bracket down and trying to straighten this spring out. On the other end over here is the mount and the bracket. So we've got the frame, the mount that goes to the frame is right here, and then we've got what's called a spring shackle, and that is what's attached to the eyelet at the end of this spring. So as this spring straightens out and curls back up, this shackle will change its angles back and forth here to accommodate the changes in that spring length. So a couple of the characteristics again of the leaf spring, multiple spring pack. It's got an eyelet on the end, on each end, and then the overall effective length always stays the same. So we've got the end of the spring will be here, and the effective length at the other end of the spring will be at the mount down here, because we've got the spring shackle moving back and forth to accommodate the differences in the spring length. So this would be a constant rate spring. The effective length of the spring is always going to remain the same. As a little side note here, we've got an auxiliary spring or an overload spring. So that 10,000 pounds that we put on it deflects that frame down, and we close up some of this gap. Another 10,000 and another 10,000. We've moved the frame down as the spring deflects until these brackets touch the end of the auxiliary spring, and now we've got an extra spring pack in here for additional strength. So an auxiliary or a overload spring pack. Variable rate spring. Here we've got another multi-layer leaf spring, a bracket here and a bracket here. This is the type that gets stronger and stronger the more weight that we put on it. So the more weight that I put on this frame with the bracket attached to it, it's going to push down, push down, push down, and try to straighten that leaf spring out. The difference here being is there is no eyelet at the end of either end of this spring, so that spring is free to slide in and out of this cam bracket or the mount that attaches to the frame. So the cam bracket here, it changes the overall length of that spring by the contact point that it has between the cam bracket and the leaf spring. So probably the overall effective length of this one here is it's touching right here and touching right here. So the overall effective length of that spring is this wide here. As I start putting weight on it, that spring will start to straighten out and it will lengthen out. So as that happens, we start to flatten that spring out. Instead of the arch that's built into it, it's flatter and effectively longer, but also we can see where that spring is contacting the cam bracket, and it's a lot closer to this end and this end right here. So we've changed the effective length, we've shortened the effective length of that spring by the more weight that we've put on it, and when we make the spring shorter, it becomes stronger. So one of the characteristics of this spring is, again, no eyelets in the end, and that spring is free to slide in and out of the cam brackets here. So we have what we call a torque leaf built into the suspension system here, into this leaf pack, so that we locate the axle from sliding back and forth in and out of these brackets. This torque leaf keeps that suspension anchored, or the axle anchored, and does not allow it to move back and forth.